Hello, welcome to Critical Change 2022. As you attend this conference, as you watch the various presentations or talk to the speakers, I'm sure you will observe that this conference is unique. As all the other conferences in project management, they tend to be about generating more reports faster or making the reports look more beautiful or collecting more data or collecting data even faster and in real time. In this conference, the focus is going to be singular, which is how to improve project delivery, how to do projects faster, how to do them at lower cost, and how to deliver them on time. Now, you would think that if we have information technology, and if we keep investing in information technology, we should get our projects done on time, because if we have better information, we can make better decisions. And if we make better decisions in a timely manner, our projects will be on time. But that is not the case. Last year, the industry spent about $10 billion on various kinds of project management software or decision support software for projects. And this number has been increasing at the rate of about 10% a year since the 1960s, when computers were first used for project scheduling. And what do we get in return? Are projects on time? No, the projects today are as late as they used to be 60 years ago. The projects tend to overrun their budgets by as much as they used to overrun their budgets 60 years ago. In fact, in some sectors, the performance has gotten worse. For example, McKinsey did a study and they found that in the last 25 years, construction projects of more than $100 million each, they were over budget by about 80%. That number in the prior 70 years used to be 28%. The average schedule overrun in the last 25 years on projects of $100 million or more in construction has been about 35%. 77% of the projects are 40% late or more. And it's not just construction. The same is true for aerospace and defense projects. The same is true, for example, in pharmaceutical. In the pharmaceutical sector, it used to take about 9 years to develop a new drug, and now it takes 10. And every time we invest in information technology and it doesn't work, the typical excuses are, hey, the software is great, the technology is very promising, it's just that we don't have good data. Or our world projects are too complicated and we just need more time because the modeling of these complex projects is very difficult. And the familiar bugaboo of all, resistance to change. Everything is great, it's just that our people are resistant to change. And what that does is, it spurs a demand for more consultants, because now you need these consultants to come up and clean your data, to help you build good models, or to help you overcome resistance to change. And you need a larger bureaucracy to maintain clean data, to maintain these sophisticated models, and to impose discipline on people. But this has got to stop. This has got to be stopped, because doing more projects faster is not just about improving a company's financials. It's not just about increasing their revenues, reducing their costs, or reducing the amount of capital they have tied up in projects. It's much more than that. It's about economic development and growth for billions of people in the world. For example, in India, the government is spending 5% of its GDP, not the budget, but 5% of its GDP on infrastructure projects. And all these infrastructure projects, their objective is simple: to provide more connectivity to people in terms of the roads and ships and ports, to make the manufacturing more competitive by bringing the logistics costs down, to bring clean water to homes, to even provide basic housing to people. That is what is at stake. And even in a country, developed country like US, 20% of our budget, federal budget, goes into defense. And all the defense projects, whether it's development of new weapon systems or maintenance and repair and upgrade of old weapon systems, all these projects are massively late. So we've got to do much better. But how do we do that? We cannot do that by banging our head against the same walls again and again. We cannot keep clamoring for better data in projects when the reality of projects is that projects are one-time endeavors. We really don't know much about those one-time endeavors the first time around. So we will never have good enough data. The reality is projects are complex, and combine that with the uncertainties in projects, it adds to the complexity. We will never be able to replicate that complexity into mathematical models in the software. And we cannot just keep throwing more and more information technology at people, asking them to enter more and more data when what they get in return is nothing. We've got to change the nature of the game. We've got to view the problem from a different angle. And that different angle, in my mind, is queues. Queues are everywhere. We experience the queues, whether we are sitting in a traffic jam or waiting in a hospital or waiting in the department of motor vehicles. But there are queues inside of our projects too. Just go and ask people who are working on projects in charge of your organization as to how many jobs they have there in the queue versus how many they are working on. And the typical answer in a project organization would be, hey, I'm working on something, but I've got 3 other tasks in front of me, right? So that is what is going on in projects. And why is that important? Because the prevalent model of projects, when we think about project planning, project execution, project optimization, we think of projects as these tasks that are nicely connected to each other. And when the task gets done, they get integrated and the project gets done. But that is not the reality. The reality is that work happens, then work sits in the queue of the next person. It sits in the queue before it gets picked up by the next person, and so on. So the reality of projects is that most of the flow time of a project is queues, not work. But if we keep operating on the model that is shown above here, then the only way we think about improving project delivery is we need better estimates of work. We need to improve the reliability of our workers so they can finish the tasks in the time that they're given. We need to make them more productive, or we need to optimize their work schedules. Whereas if you look at the reality of projects at the bottom picture, what this clearly tells you is that if you want to improve delivery, you are better off by reducing system-wide queues across the system. So let me expound on that a little bit more. There are 3 parameters of project delivery: lead time, predictability in terms of finishing the projects on time or being able to predict when the projects will get done, and the cost of projects. Let's look at the impact of queues on all these 3 things one by one. The impact of queues on lead times is pretty obvious, which is that if there's a queue on an average of 3 items in front of every worker in the project, and after a person finishes their work, what it means is before it gets picked up by the next person, is going to sit in the queue behind those 3 items. And if on an average, the time it takes to perform the work or do the task is 10 days, what it means is a task is spending 30 days in the queue and 10 days being worked on. Or out of a total flow time of 40 days in this project, about 75% of the time is being spent in the queue. So if you are tasked with improving the lead time by shortening the time it takes to do the project, where should your focus be? Work or queues? Ask yourself one more question. What is easier? Reducing the time it takes to do the work by half or reducing queues by half? Let's look at the second piece, which is predictability. And so a lot is made about task time variability. The projects are late because we just cannot predict how long a task will take. Right? So let's take the example where tasks take somewhere between 10 to 20 days, which means the average time it takes to perform the task is 15 days. The range is 20 days minus 10, which is 10 days. And if we just use a very simple measure of variability, and you can have other measures too. This measure of variability, which is range by average, says our variability is 67%. But now let's look at the impact of queues on this variability. If you have 3 tasks in the queue, the additional variability that comes in is that you cannot predict whether the task that is sitting in the queue will be the 3rd task to get picked up or the 1st task to get picked up. Right? So that variability is much more than the task time variability. For example, if you are the 1st task to get picked up and the task in front of you took 10 days to finish, then you're sat in the queue for 10 days. If you are the last task to get picked up and every task ahead of you took 20 days to finish, then your queue time was 60 days, which means your average is 35 days, the range is 50 days, and your variability is 143%. So if you have to make your flow more predictable, where should again your focus be? Reducing the queues or reducing the time it takes to do the task, or reducing the variability of tasks. Finally, let's look at costs. Now, this is a little bit counterintuitive because the theory as well as our perception, our expectation is that if we want our resources to be fully utilized, we need to have big queues in front of everyone. Because let's say I'm working on something and I finish my work early, I'm super efficient. I don't want to run out of work. So therefore, there should always be a queue in front of me. Or if the person who is doing the task before me, the feeder task, if they are late, then again, I don't want to run out of work. So there should be a queue in front of me. But this is not true. The reality is that once you increase the queues beyond a certain point, you suffer a loss of throughput, a loss of utilization because of two things in projects. There's the synchronization aspect and resolution of issues. So your work gets less synchronized, the bigger the queues, and the various issues that come up in projects that take much longer to resolve when the queues are longer. Let's look at these 2 points in detail a little bit. So missynchronization. The simple example here is there are just 2 very simple projects. Each project has a purple task, a green task, and a blue task. There are 2 of these projects. You have only 1 purple resource, 1 blue resource, and 1 green resource. Now, if you put both these projects into execution in front of the purple and blue resources, you're not guaranteed that the purple and the blue resource will prioritize their work the same. It's very much possible, and that is what happens in projects, that the purple resource might pick up the first project to work on, and the blue resource might pick up the second project to work on. So after week 1, when you come into week 2, the green resource does not have complete inputs from either project number 1 or project number 2. So they're going to sit idle. Meanwhile, in the second week, the blue resource will finish their work on the first project, and the purple resource will finish their work on the second project. So that when you come to third week, suddenly the green resource has 2 projects to do, but they can do only 1. So they finish one of those projects, and the second project goes into week 4. So what you see here is in 4 weeks, on an average, you're going to finish 2 projects. Versus if we reduce the queues, if we introduce only 1 project in the system at a time, the priorities are automatically synchronized. The purple and the blue resource work on the first project in first week. The green resource picks it up, finishes the project in the second week. Meanwhile, the purple and the blue resource work on the second project, then the green resource picks it up in the third week. So what you find is over the long term, you're completing about 1 project a week here. So 2 projects every 4 weeks versus 1 project a week. That is the impact of synchronization. And synchronization is not just at the major integration points in a project where you need to integrate subsystems and systems. The synchronization is required throughout the project. So for example, in the system engineering phase, the various disciplines, the mechanical engineer, for example, or the thermal engineers or the electrical engineers, they need to work in tandem with each other, because the design decisions in one area affect the design decisions in another area. So information needs to pass back and forth, and they need to be working in tandem. And if their priorities are not synchronized, then they're not going to be working in tandem, and the project is going to extend. The same thing happens when you have multidisciplinary effort required, for example, in the outfitting phase of a ship repair, or when you are making commercial buildings, right? So you have the electricians, the plumbers, and some other trades. They all need to work in tandem because their work interferes with each other and depends on each other. And if their priorities are not synchronized, again, everyone ends up waiting on everyone else, and the project ends up taking much longer. The second point here is that projects are not like production, where you have set a process and things will work like clockwork. It doesn't happen like that. In projects, at every step of the way, there are going to be issues. Whether those issues are related to technical decisions that need to be made by managers, those issues could be customer approvals or customer decisions that are required. Issues could be related to your vendors where purchasing people need to get involved. And when you have large queues, this pile of work in front of everyone, the issue resolution process slows down for two reasons. One is people are firefighting, so they don't have time to resolve the issues. Managers get busy firefighting, and what ends up suffering are the decisions they have to make about projects. And the second big reason is a psychological reason, which is the organization just develops an apathy. If there is a pile of work in front of me, and if I get stuck on one job, I'm not going to worry about getting that issue resolved. I'm going to just pick up the next job and keep working on it. Similarly, the problem solvers, they will think the same. If an issue goes onto their desk, they don't care about it because they know that the people on the front line, they have other work in front of them. So a combination of these two factors, missynchronization and the slow speed of issue resolution, that is what makes queues so devastating in projects in terms of the utilization of resources, in terms of the throughput or the output of resources. And critical chain is about reducing these queues and managing this flow of projects. Right? I hope that is what you will get from this conference, how to reduce queues across the system, how to manage projects with a smaller amount of queues in front of every resource, which will increase the flow of your projects, increase the speed of your projects, increase the output of your projects, and also bring more predictability into your flow. One final point I want to make is that if you focus on flow versus focusing on work, what are the implications of that in terms of your information technology or in terms of the time it takes to implement new information technology? When you focus too much on work management, about accurately estimating the tasks or creating very optimized schedules, what ends up happening is you throw a lot of sophistication at it, but your impact on project delivery is minimal. Versus if you focus on flow, your algorithms can be much simpler, your data requirements are less onerous, and you can get your bang for the buck very quickly. So for example, if you want to cut queues and if you are convinced that you want to cut queues and increase the flow of projects, you can start doing that in a week, 2 weeks, 3 weeks, not in months and years. That is the power of critical chain in my mind, how to improve the flow of projects. Thank you for listening to me. I look forward to hearing from you in the Q&A session tomorrow. And you are also welcome to contact me directly in case you want to engage in a one-on-one dialogue. Thank you again.